Hello guys, I am Jerry and welcome back to my channel. Before we start today's video, please make sure you subscribe to the channel, and if you want to see more such content, leave me a thumbs up and a comment down below. It helps me out a lot. So I hope you enjoy the video.
What's good, you guys? Welcome back to JD Journal. So we will be starting with the video tutorial series on data types in Python, and the first data type which we will be looking at are lists. So lists are one of the most commonly used data types, and they are an ordered sequence which can store homogeneous or heterogeneous data. What I mean by that is, as visible from my written blog, they can store absolutely anything. They're not limited to storing just numbers or strings, but they can store a combination of everything. That is why lists are so popular and powerful. But that doesn't mean you should have a convention where you have a list which contains different data types. I do not see any practical usage of this, but Python does allow it. So let us create our first list, and that would be something like a is equal to, I'll create a simple one, 1 2 3 4 5. So this is a list which has 5 numbers, and B is a list of 5 characters. So A comma B comma C. So we have two lists. Now the most common operations which you would perform on a list are accessing the elements of the list, or say updating the list. And for that Python provides a number of methods which you can do. So let's quickly go over some of the methods, and the first is the insert. Now suppose this is the list 1 2 3 4 5, and you want to insert another number at any index. So the lists are zero, as with any other language, are zero index. So the first index is 0. The only interesting feature which Python provides is you can also access the list from the end, and the last index is -1. So a of 0 give you 1, but a of -1 will give you 5. So this is the two ways in which you can access the elements in the list simply by using the index. Now what if you want to update any of the values? Now updating of the values is simple. You just have to give the index, and now a of 0 would be updated. Another method which is available as a part of the list API is the insert method. Now suppose you want to insert a number, say 15, between 3 and 4. So a dot insert, so 0 1 2 3. So let's try at third position, and I want to insert 15. And now if you see, between 3 and 4, the number 15 is inserted. So this is one more method which is provided as part of the API.
So now if you want to delete from a list, there are three possible options to do that. The first one is deleting using an index. So if you want to delete the third element, so remember list a 0 index, so 0 1 2 and 3. If we do a delete a of 3, then it will delete the element 15 from here, and see the newly added element is gone. Another method is removing using the actual value. Suppose you don't know the index, but you are at a scenario where you are supplied a value which needs to be deleted. Then what you can do is a dot remove of, say you're supplied the value 3. Remember, this is not the index, this is the actual value which is supplied. So if we do that, the first occurrence of 3 will be removed. Now if there are multiple occurrences of 3, then only the first occurrences will be removed. So if you see 3 was removed. Now to explain what I said before, let's just add a couple of elements. A dot extend. So what I'll do is I'll add 3 comma 3 again at the end. So what this will do is this will add two threes at the end of the list, and we'll just do a of remove again to just demonstrate that the first occurrence of 3 was removed. There is another method which is available to remove elements, and that is pop. So if we just do a dot pop, the last element which was added will be deleted, and it will be returned back to remove to perform any operations on this. So this is like the stack operation, last in first out, and that is where this is useful as well. So these are all the delete operations which you can perform on a list.
Continuing with our previous example, I've reinitialized the list of A again. Now some other common methods which are very handy, which are provided by the Python API itself, are the min, the max, and the length. the length. So what they do is they allow you to find the min, max, and length. So length can be very length is as you know is a very common method, and you would be required to use it very frequently. And if you do a length of a, that would give you the length. If you do a min of a, it will give you the minimum element. If you do a min of max of a, it will give you the maximum element, and so on. So this is how the min, max, and length API or the length methods are available. Now, if anyone is curious as to how these methods or how the single method call is making this happen, you can just do a help and list, and if you would find that the list class, so everything in Python is an object, so the list class implements all of these methods, and hence you can simply use them. So that is the internals or working of a language. So yeah. Another method which I would like to show you is so let me quickly print the list A. Now another method which the Python API provides is the count. What count does is it allows you to count the occurrences of any element within the list. Now suppose you had a list of something like say 1, 1, 1, 1, 2, 3, 4. Now 1 occurs 4 times here. So if you do a dot count of 1, it will give you 4. So a practical use case of this would be, suppose you're implementing a word counter, that anyone gives you a file and asks you to read the number of times a particular word appears. Maybe you're doing some data analytics work. In that case, you could find this useful, and so it is also readily provided by Python API. So these are some common methods which are available as part of the standard Python list API. Moving on, now we'll see sorting and reversing. So sorting is an important operation which is available, which finds a lot of use cases in your day-to-day work, and Python provides methods for that as well. So Python provides two methods. One is the sort, and the second is the sorted. Now both sort the list, and you can sort it in the ascending order or the descending order, but the difference between sort and sorted is that one of them does it in place and the other simply gives you it doesn't do it in place, but it gives you a copy which can be stored back to another list. So to understand this better, what we will do is we'll go back to the utility which I explained in one of the earlier videos, the Python tutor. So I'll just copy this list, and now if I do an a dot sort, and let's visualize. Okay, let's do everything at once and sorted of A. Let's name this B and a sorted of B. Now let's do a visual execution of both. Right, silly me. So yeah, let's close this. Now let's execute this. So we now have a list which is initialized, and if I do a sorted a dot sort, if you see, it is already sorted. If I go to the previous step, this was unsorted, but if once this is executed, this is sorted. But remember, the list got sorted in place, that is this reference, this is still pointing to the same reference. Now let's see what happens with sorted. So we have initialized the list B, and then we do a sorted, but the list B remains the same. It has not changed. It is as it was before. If you compare this, then it is not the sorting has not happened in place. So what is the use case of this? This can be used if you want to prepare a copy and you want to store your original reference. And I'll just do a last, and if you see, the list C is now a sorted version, but the list B remains same. So the essential difference between sort and sorted is sort is in place and sorted is returns a copy. Now, as I said, just one last thing before we complete this section of sorting and reversing. You can do reverse. It has an option of reverse is equal to true. What it will do is it will sort in a descending order. And if you see, it is sorted in a descending order, right? There is one more thing, that is something called as key. And key is something which you would use, say you have a particular sorting algorithm. Say you have a deck of cards and you want to sort the deck of cards in a particular order. Say you want to have the hearts first, and or if you want to have the spades first, and so on. Then you can write a custom function which does that sorting, and you can provide that custom function as a key, and then that will be sorted in the order of the key. So that is something that so this these two are optional. You're not required to do that, but that they are available, and it is good to know. Now let us go over the last operation, which is reverse. So I'll just do now. So sorting was ascending to descending or descending to ascending. Now what if you want to just plainly reverse this list? Then what you can do is, so this list has been plainly reversed. So that is another method which is available. It's not sorting, it's just reversed it as it is. So it's got gone from A to B to B to A.
So slicing is an important concept, and this is one of the most frequently used features when you're operating with lists. What you mean by slicing is you can extract any chunk of this or any chunk of this available list. So this is a sample list we have generated using a list comprehension, which we will discuss in detail. So suppose you want to iterate over this list, but you want to if you want to extract only every alternate element. So what you can do is, now the firstly, the syntax of slicing is A. So you supply the start index, then the end index, and the step over. Again, everything is optional. You can supply any one of these and it will still work. So I'll just leave it here. Let us consider a scenario where you want to print every alternate element. So what you can do is start with 0 and then just till the end. So we are not supplying an index because we want to traverse the entire list and step over by 2. And if you see, it has printed every alternate number available in this list. So this is a convenient feature. Again, as I said, lists are 0 indexed, but what Python also gives you is lists are -1 index. So if you want to extract the last element, you can just simply do, and this is allowed as well. Now suppose you want to do something like, you can play around with this, and there are any possible ways available. I'm just trying out random things. So I believe this should be to -15. So you can just traverse in any direction in this. Now if you want, now we have traversed again in left to right only. Now if you want to traverse right to left, what you would do is you do something like go to -15 and step over by -1. In that case, the list is available from the right to left. If you do so, you just have to adjust the step accordingly. The minus will give you traversing from right to left, but if you want to traverse from left to right, you have to keep this step counter positive. So step is equal to positive, then you traverse from left to right, and if step is equal to negative, then you traverse from right to left. So again, you can play around with this. There's a lot of features, there is a lot of stuff you can do with this, and this is also one of the most powerful features which is offered on the list. You can also use this feature to split the list into multiple lists. So suppose you want to split this into a list of so this is just 50 elements. So suppose you want to do C is equal to A of say suppose you want to do the first 10 elements. Sorry, then C would be the first 10 elements. So this is how list slicing works. Now you want to do the last 10 elements. So the last 10 elements would be 40 to 40 onwards, and C would be the last last 10 elements. So this is how slicing works.
Towards the end of the video on lists, there are a lot of features which we've discussed till now, but we now come to an important part. This comes with a bit of experience. This is a little bit advanced, and to gain an understanding of list comprehension, you are required to write them a few times, because at first time when you write them, they do seem a little bit scary, but that is not the case. As you progress, you will get used to them, and they are one of the most elegant features which are available as a part of Python. Now, what I mean by list comprehension. Now, you're often working with more complicated scenarios where you have multiple lists and you are required to combine them into a single list, or say a list of tuples and anything like that. There could be a requirement to iterate over different kind of lists or iterate over anything and populate a new list. So that is where list comprehension comes into place. Now we will be seeing, we'll be looking at two examples. The first is a simple one which has a list of colors and a list of sizes, and then we'll produce a list which is nothing but a combination or a Cartesian product of each of them. And then a more practical example which takes into consideration a deck of cards. So if you play cards, or if you, I mean, everyone does play cards, so let's take an example of that as well to be able to relate more to it. So what I mean by list comprehensions, so list comprehensions simplify the syntax, or the syntax for nested for loops. So let's start with this example first. Now what I have here is a list of as I said, colors and sizes. Now what I want is an output which is a list of tuples where each color and size are available as a combination. Normally, without a list comprehension, you would do something like this. That is, you write the outer for loop and then write the inner for loop, and then you would append it to an array or whatever it is. Here I have prepared a list. But you don't have to do this in Python. This is not recommended, this is not Pythonic, and this is your approach. This is also a little bit fast, it has its performance advantages. So please make a note that this has performance advantages, and going forward you should write it like this. Now if I run this piece of code, let me comment this and let me just run. So if you see, this is the output of t-shirts and this is the output of dummy t-shirts, and everything is essentially the same. So these two pieces of code have resulted in the same lines, but they are very easy. Yeah. So this line is more readable and this is less code, and it improves your productivity. So this is what a list comprehension. This particular line is called as a list comprehension. What we have done is iterated over two lists and combined it into a single list of tuples. So this is how list comprehensions are powerful. They are more performance oriented and they are more Pythonic. To be able to relate to this more, let's go over a deck of cards. Now when you or if you've played cards, you know that it has 52 cards, and each one ranks from an ace to jack, king, queen, all that 1 2 3 4 5 6, and it has 4 suits. So using list comprehension, I have very easily made here a list of all the ranks which are available to the cards. Now just let's print rank, let's print suit as well, and then at the end we have just printed out the entire deck of cards. So this is how easy they are. So what this line does is it iterates over this range from 2 to 11. So 10, 11 is not inclusive. If you see, it's gone over to 10. So the range function, the end index is not inclusive again. So why it is not inclusive? It's for a separate topic. It makes it makes populating of list and everything easy. That is why the end index is not included. So what we have here is all the cards. So these are the only card ranks which are available. These are only the suits which are available, and by the help of list comprehensions, we have then achieved an entire deck of cards. So you can use this to do whatever operations you can. Now without the list comprehension, you can imagine this would have easily. So what is this? 1 2 3 lines of code. Without this, without the list comprehension, it could easily be in a 15-20 line of code, and so that is not what you want. So this is why Python is more used now, that it concentrates highly on the code readability and the developer productivity. As you see, these two lines are more readable, and it also saves us a lot of time. Now let us look at some other common operations which you can perform, which are provided as part of Python, but you might not find these features in other language. List. So suppose you do something like a is equal to a into 2. So what will happen now is, a will be just multiplied, or it will be concatenated. The list would be, it would produce a Cartesian product of the list. That is, okay, so let us go over some other features which are provided as part of Python. I don't really find any use case for this, at least in the projects where I worked on, but they are available and it is good to know. So if you do something like a is equal to a into 2, so a is a list of 3 elements, and if you do some multiplied by this, what it will do is it will just produce copies of this. So if you see, this pattern is repeated twice. Now if you have something like a list of hello, and if you want to print this 5 times, so a star 5 would print this 5 times. So this is something which is available. Again, if you want to concatenate a list, and if you do we have a list b, remember, in this session. So if you do c is equal to a plus b, and if you print c, so c will be now a copy of this tone. So this is something which is available, and it is a good to know feature, that if you find a use case, it's readily available. Just remember the star sign, the concatenation and the star sign. That is it for today's video, guys. We have covered all about lists in Python. We have covered all the APIs which are available. A note from my side is pay special attention to list comprehensions. They are difficult at the beginning, but once you get your head around them, they're very easy, and they increase your productivity and readability of your code. Also, do not try to reinvent your wheel. Study the APIs which are available on the Python docs, and make use of them as much as possible. So that is it for lists in Python. Thank you so much for watching.